Tal.
Hi, my name is Ong Yi Ting. Welcome back to my channel. Today, my partners and I are going to explain problems in engineering field by using polynomial. Polynomial are used to describe curves of various types so people can use them in the real world to graph curves. For example, roller coaster designers can use polynomials to describe the curve of the rides. Also, engineers use polynomials to graph the curves of roller coaster and bridge. The height of a 5 minutes ride of roller coaster can be determined by the following polynomial function ht equals t power 4 minus 12 t cubed plus 49 t squared minus 78 t plus 40, where h is the height of roller coaster in feet and t is time in minutes. First of all, we are going to find the x-intercept of the function by using ht equals to 0. That is t power 4 minus 12 t cubed plus 49 t squared minus 78 t plus 40 equals to 0. Next, we are going to use the long division to find the factors of the function. The factors of the function is t equals to 1, t equals to 2, t equals to 4, and t equals to 5. Next, we are going to do the same for the y-intercept, that is to sub t equals to 0 into the function. So when t equals to 0, the function equals to 40. That means the y-intercept is 40. Next, we are going to perform the first order derivative of the polynomial function, that is 4t cubed minus 36t squared plus 98t minus 78. Determine the point where the function is not changing, that is 4t cubed minus 36t squared plus 98t minus 78 equals to 0. Next, we are going to perform the long division again with the factor t minus 3. That means the whole equation divided by t minus 3, and we get t minus 3 and 4t squared minus 24t plus 26 equals to 0. We are going to use the quadratic formula to get the factors of t, which is t equals to 1.4189, t equals to 3, and t equals to 4.5811. So we have to determine from the 4 interval in the table. We have 4 interval. So for first t minus 3, the first interval we get negative, and negative for the second one. And for the third and the fourth, we get positive. For 4t squared minus 24t plus 26, the first interval we get positive, and the second and the third is negative, and positive again for the fourth. So the function ht is negative for the first and the third interval, and the second and the fourth interval we get positive. And finally, we know that h is decreasing on 0 and 1.4189. H is increasing on 1.4189 and 3. H is decreasing on 3 and 4.5811. Finally, H is also increasing on 4.5811 and 5. From the above calculations, we have the points t equals to 1.4189, 3, 4.5811, and t equals to 2.0871 and 3.9129. And we are going to sub those points into the function of ht for the following, for the sketching of the graph at the back. Thank you. Next, we are going to check if concave up or concave down. by performing second order derivative. That is 12t squared minus 72t plus 98. And the second order derivative equals to 0. By using quadratic formula for 12t squared minus 72t plus 98, the roots are obtained from t equals minus b plus minus square root b squared minus 4ac divided by 2a. And we get t equals to 2.0871 and t equals to 3.9129. When t is between 0 and 2.071, the second order derivative of h is bigger than 0, which implies ht is concave out in 0 and 2.0871. When t is between 2.0871 and 3.9129, the second order derivative of h is smaller than 0, which implies that ht is concave down in 2.0871 and 3.9129. When t is between 3.9129 and 5, the second order derivative of h is greater than 0, which implies that ht is concave up in 3.9129 and 5.
Okay, I am Lee Chen Yang, then I will continue the following explanation. To get the inflection points, we will take the 2 points. First is 2.0871 and second is 3.9129. First, we assume another 2 points for one is less than 2.0871 and another one is more than. So we take 2 and 2.5. Then we start in the second order derivative. Then we will get 2 and negative 7. Then the same thing for 3.9129. We assume another 2 points is 3.5 and 4. When we sub, we get negative 7 and 2. So we can see the first point, the 2 is more than 0 and negative 7 is less than 0. So we can know that hash change is concavitive. Same thing for the second point, 3.9129. We get negative 7 and 2, which is one negative less than 0 and the second one is more than 0. The hash also change its concavity. Then when we sub the 2 points, which is 2.0871 and 3.9129 in the equations, we get 0.5276 and 0.5276. They are same. So final, the points of inflections are 2.0871 and 0.5276, and another point of inflection is 3.9129 and 0.5276. Okay, next, from the calculation before, we know when hash prime t equal to 0, we will get 1.4189, 3, and 4.5811. Since hash prime t is a polynomial, it is defined for all t in the interval. So we sub 1.4189, 3, 4.5811 into the function. Then we will get negative 2.25, 4, and negative 2.25. Then we are going to find the value of hash at the end points. So when t equal to 0, we know that hash is equal to 40. Well, when t equal to 5, we know that hash is equal to 0. So from the 5 values, hash has a absolute minimums at hash 1.4189 and hash 4.5811, which is negative 2.25. Well, hash also have an absolute maximum at hash 0, which is 40. Then we are going to use the first derivative test for the relative extreme. At t equal to 1.4189, we assume 2 points, which is 1 and 1.5. We sub 1 and 1.5 into the hash prime, we will get negative 12 and 1.5. So at t equal to 4.5811, we assume another 2 points, which is 4.5 and 5. When we sub the 4.5 and 5 into the hash prime, we will get negative 1.5 and 12. Since for the 2 points, which is 1.4189 and 4.5811, the hash prime t1 is less than 0, well, the hash prime t2 is greater than 0. So, we know that hash has a relative minimum, which is negative 2.25. Finally, we get at t equal to 3, we assume another 2 points, which is 2.5 and 3.5. We sub 2.5 and 3.5 in the hash prime, we get 4.5 and negative 4.5. The hash prime t1 is greater than 0, and the hash prime t2 is less than 0. So, we know that hash has a relative maximum, which is 4. And the conclusion is, we get the critical points. The first critical points is 1.4189 and negative 2.25. The second one is 3 and 4. And the last one is 4.5811 and negative 2.25, which are all stationary points. Thank you.
My name is Tiong Lin Kai. So we get the graph from the for the polynomial function, which is h against t. So we have the problem. The problem is that the practical domain of the graph, that is the actual right. So we have the solution from graph. The domain is 0 and 5. Then the second problem is state the particle range of the graph, that is the actual right. So we have the solution from graph. Range is equal to negative 2.25 and 40. Then the third problem is, do the graph sketch above represent h as a function of t or not? How to determine it? So we have the solution is, yes, it does. We can determine whether a graph sketch represent y as a function of x or not by using vertical lines test. From graph, the vertical line intersect the graph only once, one point of intersection. So then the graph represent a function. And the last problem is, are the values of h when t is between 1 and 2 and t between 4 and 5. Make sense? Why? So we have the solution is, yes, they are. The negative value of h means that the right dive below the ground. Thank you.